Bismillahirrahmanirrahim. Once again, this is a video about some basic inequalities from sets. So let A and B be two subsets of R. Prove that if A is included in B, then we have the supremum of A is less than or equal to the supremum of B, and the infimum of A is greater than or equal the infimum of B. Let us get started. So we prove the first one. A included in B means that for all A in A is in B. So for all A in A is less than or equal the supremum of B, because here we suppose that A and B are two subset, bounded subset, and that the supremum, the completeness axiom, is valid. And since A from A in A, this implies that A is in B. So for all A in capital A is less than or equal suit B. But since supremum of A is the smallest upper bound, in this case the supremum of B is considered as an upper bound of A, but the supremum of A is the smallest one. Since the supremum of A is the smallest one, so the supremum of A is less than or equal the supremum of B. This is all what we need. About infimum, we will follow the same way, using the same arguments. So A is included in B. This means that for all A in A belongs to B. Then the infimum of B is less than or equal to A for all A in A. So the infimum of B is a lower bound. Of A, but since infimum of A is the greatest lower bound, thus the infimum of A is the greatest one, so this is greater than or equal to the infimum of B. This is the proof in a very simple way. we can prove another so famous equality. Let us suppose that A and B are two bounded subsets from R. We can prove that the maximum between the supremum of A and the supremum of B is equal to the supremum of A cap union B. So we will use the previous result. We have A is included in A union B, and B is included in A union B. So this, using the previous result, this gives us that the supremum of A is less than or equal the supremum of A union B, and the supremum of B is less than or equal the supremum of A union B. We take the supremum on the both sides of the two inequalities. So we take the supremum here and the supremum here. They are the same thing. So this is less than or the supremum, the maximum between the two supremum. It is the supremum of A union B, and we take the maximum here between them, so this will be the maximum of supremum of A and supremum of B. So we have this first inequality. So we have this first inequality. For the second one, we can suppose that the supremum, the maximum, we can suppose that the maximum between the supremum of A and the supremum of B is equal to the supremum of A. And by symmetry, what we are doing here, we can repeat it if we take supremum, the maximum between them equal to the supremum. So let us suppose this one. So for all x in A, this implies that x is less than or equal the supremum of A. And for all x in B, this implies that x is less than or the supremum of B. But since the maximum between the supremum of A and the supremum of B is the supremum of A, this means that for all x in the union of A minus B, this implies that x is less than or equal. If x is in A, this is less than or equal supremum of A, and if x is in B, this is less than or equal to the supremum of B. But we suppose here that the maximum between them are the supremum of A, so in both cases, this is less than or equal the supremum of A. So the supremum of A is actually an upper bound, of A union B. But since the supremum of A is the lowest, the smallest upper bound, then we will get what? We will get that the supremum of A union B is less than or equal the supremum of A. And by the same technique, we can get that the supremum of A union B is less than or equal supremum of A. Or in a very simple way, we can say that they are symmetric, A and B. And the proof that fits with supremum A can fit with supremum B, and we get, by the same way, we will get the supremum of A union B less than or equal the supremum B. And we take the maximum between these two, the double inequalities, the first one and the second one, and we will get that the supremum of A union B is less than or equal the maximum of between supremum A and supremum B. We have double inequalities in two different senses, so we have equality. Using the same technique described here, we can prove, you can guess it, you can prove that the infimum of A and B is equal, the infimum is equal to the minimum between the two infimum. We repeat exactly the same techniques. This ends this video. Thank you very much. See you inshallah very soon.